All right. It's exciting to be back here for session four. And I'm Ilya Tabakh, one of your hosts. And I'm here with Barak Turovsky, and we have a guest, Tab Schadt today, who's going to share some really awesome insights with us. So, maybe we'll start with, Barak and I have an interesting sort of views into this background. I mostly come from the infrastructure, power, data center architecture side. And Barak, why don't you tell us a little bit about, the perspective you bring to the table?
Yeah, so I'm coming more from AI practitioner, so AI operators view, and my fun slash semi-cynical view to introduce myself that I worked on those quote-unquote esoteric topics like AI and large language models roughly 10 years before it became the hottest thing on earth. On more serious note, I effectively launched first commercial LLM or productized LLM with Google Translate when I spent 10 years at Google, which led to transformer paper, which led to groundbreaking technologies like BERT, that basically was a stepping stone towards ChatGPT, and the rest is history. So definitely very excited to talk about both angles of demand, AI demand, and supply, power, energy, data center, etc.
Awesome. And today we have Tab joining us. So Tab, I'm hoping that you can give a little bit of background, who you are, and also maybe tell us a little bit about Liftr Insights and how you guys got to be where you are today.
Absolutely. Thank you for having me. So much like yourselves, I many years ago, maybe let's call it 2 decades, we started hosting communications companies in which the infrastructure was not so readily available. You were building the data centers, dealing with power, redundancy issues, and so forth, and just the sensitivity and the service level agreements. So that was really the culture we built. It was very much of a uptime is everything, and how do you fit the application into what you were provided? A box with something you needed to, hand weave yourself to make work, or you could just take it the way it came. And as we know, sensitive applications really they need a lot of sensitivity. They need a lot of love and care. So building out data centers was a way that we became very comfortable with the power requirements and the infrastructure, the security, everything that goes into that. As we transitioned out of that business, we started to provide enterprise support to the state of Texas as an example, under what they called the cloud service brokerage contract. And what that meant was we have a lot of applications and a lot of servers all over the place, and we need to get them into the cloud. And this is, circa, call it 2010 at the time, 11. So that's a heavy ask because when I say all over the place, they were all over the place. And you can't affect that particular application on voting day or registrations for a driver's license. And so very disjointed. But we took the approach of being a multi-cloud provider during this process. So we did not want to recommend one particular cloud provider. There was just too much innovation in a unique way coming from different areas, but it was hard to get your hands around. As we then exited that business, we were in the business of data. We said we answered a lot of questions along the way, a lot of PO questions. How do you budget for a Microsoft or a Google or Amazon and on, buy versus build? So this became institutional knowledge, if you will, kind of tribal knowledge of what does it look like to spec out the CapEx, the energy cost for these virtual environments, these hosted environments, everything from compliance to what's it going to cost total, expense. What's the real cost here, the TCO? And in doing so, we decided that we brought in experts from the supply chain industry, actually, folks that were engineers and built chips and were involved in the marketing of such chips, to look at our data and help us better understand how to use it. And initially, it was the supply chain through market intelligence and competitive intelligence for people to actually see, are they keeping up at the pace of innovation? Or are they losing to their neighbor and they actually think they're doing well? So a little bit of FOMO, but at the end of the day, really it was they're deploying faster than us, which ultimately gets scoped to cash to, deployment to the financial side. Then we realized there's a strong interest in alpha for financial services companies. So this signals that put the investor ahead of the earnings that they might hear or the noise that they might hear on Wall Street. So one of our jobs was to keep those executive announcements and to keep those things in check and look at it from an objective standpoint with data that would prove that. And so in doing so, our framework is at a very, very high level. We enumerate the unique instance types across roughly 82% of the public cloud infrastructure. And we have a little over 6+ years of doing that. So the back testing, the analysis, the regression pieces, to get to that, those high accuracy numbers are something that we do. That's what we do on a daily basis at Liftr.
No, it's awesome. And it's funny because we've kind of approached this question from a different perspective. I know when Barak and I were talking about, making infrastructure decisions, there's sort of from the view of an operator when, kind of Barak was talking about his experience with Google Translate. And it's interesting to sort of think about, kind of one of the other perspectives. How is the, kind of market adapting and providing supply? Because a lot of folks are starting to think through kind of what this means to them and make strategic choices on build, buy, partner, and there's new entrants showing up like the neo clouds. And so really interesting to sort of think about that and dive forward. I do want to take a little bit of time to kind of work through, kind of zoom out a second and give you guys this orientation of, Barak and I have tried to organize all these different discussions into, a framework to help everybody kind of understand what are we talking about. So let's take maybe a minute or two to just remind everybody what the 4Cs framework is and kind of how it works. At the basic level, everything is really driven by what is the kind of consumption, the demand. And we're not going to be talking about that too much today. But generally, we'll start to think about where are interesting points of data and information. The second C is cognition. So that's like models, data, things like that. And so there's a lot of information coming on kind of what is the performance of a model on GPU and things like that. There's a lot of important data there. But really today's session is going to focus on compute, and specifically we're going to look at availability of accelerators and GPUs in the public cloud. As Tab described, his data set covers, the majority, about 82% of the public cloud instances. And there's some interesting insights that will come there. And then the final C is capacity. So we're thinking, power grid, water, real estate information, and kind of at the tail end of the discussion, we'll dive in a little bit on where are other data sources and data points that are really important to this discussion. And then, one of the things Barak really likes to talk about is the timing mismatch. So just a reminder for everybody about the timing mismatch in this area.
Yeah, so one thing that I discovered doing it many years ago, and just for another refresher, 10 years ago, Google decided to build custom chips, TPUs. That's the processing. And one of the reasons that at that time, GPUs could not provide a good performance on inference. And we had to scale them because Google Translate is a huge product. It's like more than 1 billion users, 140 billion words translated every day. And we encountered that. So on a high level, the demand is pretty fluid. It can change in a matter of days a week. One day we all excited about all those applications. Next day we feel, it will take longer, and then you need to adjust. And then we're going to, on the supply side, you basically have cognitions, the models that, yes, now it's easier to develop them. So it takes months, maybe up to a year to develop a new model. Compute, it's still, the moment you go into physical things, you immediately have, longer time cycles. So it's 12 to 48 months. And in many cases, it's closer to 48 months. So then when you go to capacity, you're talking about 4+ years at minimum. In many cases, you need to make, or, if you're going to a county, you're going to a utilities company and you make, hey, I need that type of demand. I need this capacity to meet this type of demand. They're basically saying, hey, our planning cycle is a year, 10 years, and you need to commit to 10 years and we will fund it with a bond. By the way, I'm only pretending that I understanding the space. It all came from Ilya because I looked at it and I understand the issue. I understand the problem statement. But the bottom line is that because of this mismatch, you will always should assume you might get it wrong. The key is to make sure you understand it really well and try to optimize within these constraints. You will not be able to eliminate them. You will not be able to create a supply that will be completely fluid. But you can start thinking about, you can start it from an investment perspective, from AI practitioner perspective, from everyone's perspective, try to understand how you can optimize it. And that's why we're bringing such great guests like Tab to talk about it. And actually today we'll focus more on the compute side. And there is very interesting and exciting insights that he will share with us. Welcome, Tab.
Yeah, absolutely. And I guess one more thing to add to Barak's comments. I think there are actually really interesting insights and data points on capacity. So if you think about like the interconnection queue, how many power plants are in line to connect to the grid? If you look at sort of industrial real estate information that comes from all kinds of good places, CBRE, JLL, lots of others are reporting on this info. So we'll be looking at those data points and maybe even like thinking about which ones should we be thinking about at the end of this discussion. But let's spend a little bit of time on sharing some of the public cloud insights that Tab has brought to us and kind of talking through some of his views. So Tab, I'm going to bring up your kind of first slide to give a little bit of insight to folks and ask you to kind of talk about it and what's going on in the public cloud.
So no surprise to anybody that it's so hard not to have an NVIDIA-centric conversation, even if you're trying to avoid it. It is what it is. I'm not a big fan of that phrase, but I mean, there's a lot of blue there. But there's advancement. But the fact of the matter is they came out of the gates, they came out very strong, but there are competitors that are looming, albeit not at a rapid rate. But as Barak mentioned, where we are in the adoption and the technologies that are on the forefront and the planning and the dollars need new entrants and competition. So the liquidity and the investment is out there to see less blue, if you will. And by the way, it's not a knock on NVIDIA. They just did a great job at the right time, the right place. And so that's a lot of market share you have to go after. And you can see, and then we'll go to 25. This is a year over year. You can see AMD did a good job. They did a good job of cross cloud, platforms of getting in the door and then expanding. And that's clear. Still a long ways to go, but they executed the model right, and they kept their eye on the ball, knowing that it's a long haul. You can look at AWS and see that they're going to always be the contender, and they're going to expand, but it's going to be mostly in their silo. And then GCP, they have a very unique way in which they deploy. In fact, they are growing, but the way that they deploy and their instance types, if you will, are in a different nature. They're more in a pod format, to where if you're counting them, you may see one, but as Ilya and I were talking, for a metaphor, and I apologize if it's a cheesy one, but it's a mansion, but it has a whole bunch of little houses inside of it. Well, it's really hard by design. That may be considered one, but there's a lot of innovation and a lot of different types inside there. So there is more growth coming from GCP than this chart recognizes, based on the methodology and what's available to count. And then you have some of the unspecified, portions, which read the gray, and that's the alley-oop. Unspecified, it's real simple. There's supply chain issues. They're very active, but they don't have clear branding or products. Think of it as a SKU, a share of shelf in a marketplace. They're tinkering with things that the cadence doesn't allow to exactly track it apples to apples, which is what Liftr does to make it more consumable. So there's that gray area, literally, no pun intended, for unspecified. But the rest, you'll see the growth of Oracle. Amazon's going to continue organically. And then Google is making a bigger bump than that chart shows. but they also deploy differently.
Yeah, so that's a great insights, Tab. And I actually have one quick observation and then a question. So observation is that I think it's a very good news for everyone who will start to look at that, because if there is still a supply constraint, more suppliers means that you can fulfill this supply faster. That's great news. Also, I assume if supply is not growing as fast, also it will probably put some downward pressure on pricing from NVIDIA, because they're not the only game in town. Would you agree with that assessment on a high level?
Absolutely. And then you also have what we're going to get into a little bit. You have the more efficient providers that understand the framework and architecture and have fresh money, if you will, that is addressing power. So not only are they going to be CapEx competitive, they're going to be efficiently competitive in power. So you're going to see this sub-market, if you will, rise quite a bit over the next 18 months.
No, that's great insight. And then one additional, maybe slightly biased question, since it was in early days of using GPUs. I'm actually very surprised, pleasantly surprised on progress from AWS. I assume it's their custom chips. But I'm also slightly surprised that in 2025, you see a lower share of GPUs for Google, even though GPUs is the most mature custom chipset product. I'm just curious, what are your insights on that? Part of it you maybe address because they do it differently, but I'm just curious to hear a little bit more.
Well, it goes back to that, their deployment methodology, right? So they're deploying inside of a pod, but they're deploying many different types, like a Baskin Robbins of ice cream, but it's under one roof. And where the others are one-to-one, they're one-to-many inside their deployment methodology. So they have grown year over year. Now, but if you were counting one, they have many behind one. The rest,
okay.
The rest are ones, one-to-one. So that's the detective work and what we do to normalize this to apples, because so it's consumable for the financial investor to seeking alpha or the market intelligence, because that is a significant takeaway, is to say they're not going backwards, they're just deploying differently, and then they'll change that when they feel right.
Got it. No, that's helpful. And I assume AWS, I will make an assumption, please tell me if you agree or not. Obviously, there's a big gorilla in terms of absolute dollar and absolute deployments are very motivated to reduce costs. So I assume, like, to some extent, GPUs for Google, historically it was performance, not necessarily immediately cost, but now it's way better because they don't need to pay NVIDIA margins. I assume AWS aggressive push, it's also related to margins, right? It's not necessarily performance is better of those custom chipsets, right?
No, they just have pricing leverage, so they're going to go faster because they have the organic advantage. Which, if you look, they're the only ones that have that much attrition, meaning going to get what NVIDIA has. Other than AMD, the only other way to do it is a multi-cloud approach, because there's less pricing leverage, so you have to go across many different clouds or several. So yes, your answer is right.
Right. And just to follow up on that real quick, one of the interesting challenges, correct me if I'm wrong, what I'm hearing from the market is that AWS chipset is not comparable to NVIDIA, meaning performance is still not there, not comparable to NVIDIA latest and greatest hardware, not comparable to TPUs. AWS is driving big share of their overall deployment using their own custom chipsets. They will need to push it aggressively to customers. So how they will do it if performance is not the same? I assume pricing, right? How they will entice people to use their custom chipset? Well,
first of all, it's such sunk cost that it's a way for them to enter. So think just strategically, it's been paid for over and over and over. And I think one of the misnomers is that everyone needs the latest and greatest. And we're going to see that that's where AMD made that move. But the reality is, a lot of people, this is still them coming out of their comfort zone. And, do I build? Do I buy? Or is this the place where I go try it? Do I go train it here? Do I figure out, can I fail here and have another day, right, to live? And sometimes a B-level product at half the price is the place to do that. So you have different personas of people, and that's the way that Amazon's using their technology. And then when they see those trends, as we know, they're very good at saying, okay, now that's a premium service. So
absolutely, that's a great
their ability is there, but they're going to carve out a chunk and address a roadmap. That's what we're seeing.
The other thing to think about is when you are able to integrate your product offering and sort of the software stack and be able to control sort of what happens on the hardware, you get some pretty interesting, opportunity to optimize your hardware and software for your application. And so, I think folks are pretty excited about how TPU performs for Google internal applications. And I think there is some use cases where you can sort of take that advantage that may not be offered through CUDA or through other kind of software methodologies. And so that's kind of the other thing that's at least being talked about. Now, whether that actually materializes in performance end to end is a different question. But at least, strategically, there's some interesting levers you can pull.
And just to finish on this and echo, I mean, Amazon has a position, a unique financial position and a customer base that is legacy embedded and doesn't want to go anywhere. Some that are stuck and aren't sure how to get out. And then they have new entrants, models. But they also have the ability to provide a lab type environment, which is kind of what you were saying. And I don't mean that lab as in it's a false product. It's actually the market is giving them the requirements on what to build, and they won't go anywhere if you do that. That's very powerful. Whereas if you're having to build it, you heard what they said, but you hope it works. Whereas some of these customers in Amazon, they're not going anywhere. They're just saying, build this to spec. And that's a very competitive attribute.
Absolutely. I just want to emphasize to a lot of our listeners, especially AI practitioners and investors, it's very important to put the supply to meet your demand. And what I mean by that, not every use case in AI requires ton of cutting edge GPUs. That's what today everybody is chasing after. Because think about it in the following ways. For example, let's take search, where I worked for many years. In search, it's actually, you need everything. You need super high latency, super low latency. You need super high freshness, meaning the model needs to know a lot about recent events, and you need relatively high accuracy, right? All this creates a situation that you need cutting edge GPUs or TPUs like Google does. But there is a ton of use cases you don't need it. Just an example, let's say in legal, you want to create, a lawyer is doing research and he needs a memo. He can probably wait several hours. That's why all those tools like, deep research from OpenAI or Microsoft just launched Researcher and Analyst, they take time. They can take 10 minutes, can take half an hour. That's a huge optimization on your GPU cost. And to Tab's point, then you can match your needs to like maybe a bit lower grade hardware. You don't need to go to all the latest and greatest hardware. Sometimes you might even go to CPUs if needed, depends on the needs, right? It's really important for AI practitioners and investors to understand when they look at those. You don't necessarily need the latest and greatest hardware all the time. You need to look at your need and analyze it and understand whether the latency, low latency is important, accuracy that impacts the size of the model, and freshness, because freshness obviously requires a ton of GPUs.
It's the business user, right?
Absolutely.
What's the solution? Is it to the solution doesn't require the Ferrari, the newest thing. It doesn't. If it can be accretive to the business unit and the data science team understands that, then it's perfectly acceptable to go in with a certain product type in mind. And it doesn't mean it needs to be the best. It just really what we see. Companies are using what's there to solve a business need, but it gets them comfortable with how to do this going forward, which is what's happening now. Like when we get to another graph, now companies are getting comfortable with letting go, right? And that starts with a basic business use case that's accretive to the business. And to your point, it doesn't require the most expensive. Well, again, this is a global basis. Again, if a unique instance types is for sale, and I'm moving fast on this. We catch 100% of it across the globe if it's for sale. Now, sometimes they go to preview, sometimes they delete an entire region or zone, which is very interesting data insights that we have too. Is that because they totally misread the market. It did not work. But if it's for sale to the public and it's deployed, then we capture 100% of that globally for the cloud providers that we track. And what you'll see is what we've been talking about. And NVIDIA is just dominated through Infertia and Ampere. Gaudi flat, that's a whole different story, but they gave a run at it in terms of execution and again, NVIDIA being at the right place at the right time. But if you look at the top left, and this is kind of just to fast forward, the machine intelligence, which is the brighter green growth, that's AMD. So that brown on those charts, that attrition, that's AMD. So this is the inflection point where you had this out of the gate dominance. But now that you do have people more comfortable and you actually do see the machine learning models and the neural networks and they really are picking up pace, people do want change and they do want to adopt. And so that's a global look. So this is Grace Blackwell and Hopper. And if you look at the deployment, it's not just speculation. It's happening, and it's happening very, very quickly. And what's important is we're asked, well, that's just because that's the U.S. or it's some major, continent or a particular, part of military. There's some underlying reason. Here's Latin America. These were up and running faster than any others in this particular area of the world. So you can call that what you want to, but that's not the U.S. and it's not, sitting right in the middle of the most dominant place, maybe in the EU or wherever that may be. So people want this technology. It's moving quickly. And that's why you see the AMD capturing that growth. And it's not just in a place like the U.S. It's in, San Pablo and so forth. And then this is the breakdown of that, just another version of what you saw globally, but it's the same trend. It's the same trends happening in secondary and tertiary and smaller markets. So you're going to see more attrition because it's not just a one-off or an anomaly in just a very large market. It's actually a global basis that when the new comes out, it comes out. And so people are ready for the change. But back to Barak's comment and mine, that big orange in AWS is still very, very, very valuable for the people that want to maybe tiptoe or use it for testing environments. And it's a win-win for AWS and the customer.
Yeah, maybe just a couple of things to call out that I was looking at the overall distribution. Some of this graph is pre-Chat GPT, some of it is post. But when I see it, I'm also seeing some things because each one of these architectures has a different power density. They also have sort of a different network connectivity and throughput, right? And then the other part is you're actually seeing a lot of the timeline for deployment and adoption really compress. Both NVIDIA and AMD have recently kind of committed to 12-month rollout of platform. And so, those are kind of some of the things that I saw. And obviously the fact that Gaudi flatlined, was also kind of interesting data point. But just wanted to sort of call out a couple of those things because as you think about the data center infrastructure and also kind of the power dynamics of deploying, large AI factories of these, that has a real impact on kind of the physical and sort of capacity side of the world as well. So it's not specifically called out here, but I think it's an important consideration.
Well, and once they're up, to your point, at the beginning of a quarter, you look at that number, it's up and running. Once the facility, the factory's up, you're talking, 90 days. So think what that does to the financial markets. So there is the big build to get there, which the energy is every conversation that we are involved in ends up with power and water. How are you going to cool these things? And the public grid's not going to do it, and you don't have just reservoirs setting aside for AI. So there is that topic, but it's just picking up pace once they're off the ground.
Yeah, absolutely. One question, the reason I sort of brought up the power part up is there was a question that came in about kind of transients and what are people seeing for load. We were not going to zoom in on that question today, but I think it is important to know that, as we get into the Blackwell architecture and also some of the 325 and 355 from AMD, we're talking about 700 watt single GPUs, right? And also rack densities that are crossing the 200 kilowatt threshold. And so as you spin up a rack that is essentially a neighborhood, there's a lot of things that happen there. So maybe just to call out to the person asking that question, the DC Flex initiative from EPRI, which is the Power Research Institute, they're doing a lot of work and try to kind of bring these loads and what to expect and things like that. So just wanted to kind of address that question.
Yeah, I mean, it's one that, I mean, there's initiatives in every parts of the government right now. I mean, for instance, there's a organization that we're very active with in Texas called the IT Caucus, and it's how you handle this, because the stakeholders, especially at the public level, they want more votes, right? They want to get that vote again, and they want to create the jobs, but at the same time, they don't want to have a brownout. To your point, when these racks are turned up. And so there has to be the alternative piece to all of this, and it's a complicated issue, and one, quite frankly, that the infrastructure today, obviously, the whole point is it's going to take more time. It's just going to take more time. So what we've been told is that there's just going to be a lot of outside money. There has to be. This the amount of money to solve this problem. If you just look at it, the gap is not like 2 years or 3 years. It's the rate at which it's moving, it's like, decade plus, just to take it. And that's not an NFL market. If you just take like you said, a neighborhood creates 5,000 jobs, homes outside of, 30 miles, 40 miles outside of an NFL city, they have a real problem where they have to have an energy source that will come in off the grid. And in terms of the kilowatts, we've heard closer to like 250 than 200 as they scale.
On the last episode, we were actually talking about Google contemplating a megawatt a rack and starting to put out those concepts. Also at GTC this year, NVIDIA talked about their kind of 2 generations from today taking about 600 kW a rack. And so and today there's installations that are being directly water liquid cooled at 125 and 200 being deployed in some of the neoclouds. So it's we actually dove into that a little bit with Sean James from Microsoft last time. It's just crazy to think about those numbers.
That's why it's so key. These the startups or the well-funded competitors into this NVIDIA channel, their value prop is power, right? Because they can solve that quicker. I'm not saying they can solve the actual problem itself, but they can come in with a design that can take a little bit of heat off of that problem, that issue. I mean, that's one of the biggest value propositions, if you can address that. Not only does it cost less, but it addresses it's not even the elephant in the room, it's the main topic every time these discussions come up. So it's one that just has to be dealt with. So if you can build that into your product now, you have more than a puncher's chance.
Yeah, well, and that's what I love about, I think as we sort of ended up on the tail end here, that was kind of the whole point about bringing together different perspectives and different types of practitioners, because, the puzzle pieces, when you fit them together, help you sort of elucidate this whole story. And, to your point, you're talking about kind of these 5-year, maybe 15-year, 20-year commitments for the data center, maybe 30-year commitments for power. A lot of the infrastructure, if it's coming out in 12-month chunks, right? Maybe that's a 2 or 3 year commitment. So it's kind of interesting to think about. One of the things I had here, and I'm still waiting for kind of questions to come in last second here. So please submit your questions and we'd be happy to pick one of them up and talk about it. But one of the things that I had sort of as we were getting prepared for this conversation is, wanted to actually ask Barak, what kind of trends and infrastructure things are you looking for to sort of change some of these dynamics, or, kind of what's on top of your list? Because I have a couple, but I'm just curious to pick your brain about it.
Yeah, so one thing that obviously my level of expertise is more on the demand side and cognition side on the models, less about the data center, etc. So that's why I'm so keen to get those perspectives from you guys. On the, obviously, demand, you could try to optimize demand, and we talked about it, exactly what I mentioned. Not everything is the same level of demand as search. You cannot always assume that you need super low latency, super high quality of the model that impacts model size, and super high freshness. You need to be very specific. And I encourage every AI practitioner and investor, when they talk to their, if they're sitting on the board of a company, really, really, really scrutinize our assumptions. So that's the first thing. And that impacts a lot of things related to models. But at the end of the day, it propagates all the way to GPUs and to power, right? If you're saying, oh, I will have 1 billion users and all of them will need the use case like search, super low latency, super high accuracy, super high freshness, you're basically stuck, and you need to prepare a big check from your investors, right? To basically be able to do that. People need to really think through, and to large extent, question their assumptions. I will give you an example when we did it even in Google Translate, which is very close to search. We were in a situation that performance was slow. Initially, the inference was 100x slower than production, meaning instead of, let's say, 1 second end-to-end, it was 100 second end-to-end. And at Google, for 100 seconds end-to-end, you would be fired on the spot, right? So we started to really play with it, and we did all those techniques, distillation to shrink the size of the model. And then we developed TPUs. But we actually started to test what would take users to actually say, what is their tolerance, right? So we artificially, believe it or not, literally slowed down Google Translate, initially from, let's say, 1 second to 2 seconds, and then to 4 seconds, and then to 8 seconds, just to see where users will start actually, user behavior will start to be impacted. And what we found is only at 8x, 8 seconds, people will start to see a drop-off. It's really important even for, super religious approach to latency like Google to literally question those assumptions. And let's face it, not everything is not search. There is a lot of use cases in enterprise that people will be totally fine to wait for 10 minutes to get a well-worded memo about as an example I gave, let's say in legal or in financial research, etc. So I think that's where I focus a lot of my energy.
In the overhead, if you ask somebody to put a value on the security of that, if your VPN infrastructure security would slow it down, a lot of companies would say, I'm willing to take that hit, right?
Exactly right. And you nailed it. It's all about the business case, because business case is not only what is the value you get from the customer, but also your margins. Hey, if your margins are low, don't even try to compete in the Google search space, right? It's like, it's not going to work for you, right? All those things needs to be, but people really need to question those assumptions that everything needs to be super fast. Yes, it would be great to have it super fast, but in many cases, when you combine two use cases, one is reasoning or research, and the second one, really well-written, what I call fluency, like real well-written memo or document. People saying, you know what, you're saving me a day of research. I'm okay to wait half a day. I'm okay to wait 10 minutes. I'm okay to wait an hour, right? And believe me, an hour of wait will dramatically reduce everything on the supply side, right?
Absolutely. Yeah.
Well, and actually that dynamic. So one of the reasons I was excited to kind of engage with Barak and think about who else are we like leaving on the side of the road here is, as we talked about it, last episode or last session, Sean mentioned that, hey, maybe not every data center needs a power backup generator, right? And that is directly driven from what's the use case, right? And also there's some technical performance, like how long and how expensive does it actually take you to set a checkpoint and then recover from that checkpoint? Because if that cost is lower, then you may choose to turn off when you have a power deficiency, as opposed to turn off your turbines. And that's a conversation that just does not happen, right? And so if you don't understand what the goal is, you can't optimize.
Exactly. And Sean was phenomenal, by the way, because of that military background, that at the end of the day, I learned the hard way when someone said you're fully redundant, ingress and egress out of a data center.
Yes, that costs you.
And then I'd say, oh, am I sure about this? And I'd look at the topology map, and you'd be like, okay, maybe for like a football field, and then they cross over, and then they keep crossing back over. And then you go, this is not fully redundant. This is, maybe you're bringing more bandwidth in. And so but maybe that's okay, right? For that new AI application. But again, to Barak and all of our points, it's really what's the business case? There's got to be a service level agreement. It's tied to revenue. It's either acceptable, it's not acceptable. But the layers, those old school, if you will, layers, like you still need terrestrial type support to do some of this. And I think people forget that it's code, it's engineering, it's innovative, but at the end of the day, you still have to go back to the infrastructure and really analyze that.
Yes, and I want to emphasize that point up. I think one of what I saw among AI practitioners coming from that world, AI practitioner investors, infrastructure will be resolved. And if we have a temporary challenge today, like memory, when we had a big blow up of a Japan earthquake or whatever, it will be resolved in a year. Well, that's the problem, is that you need to understand the timelines of the physical infrastructure and understand it's not as fluid and not as easy to adjust as you think. And that's why people need to assume that the shortage will be there and it's not easily resolvable tomorrow. And obviously, we will all want to optimize on the physical side as well. But don't forget that you can optimize a lot on the way more flexible software stack and product requirement stack, which will be way easier.
Yeah. To go get right away and start digging more trenches and laying more fiber takes a lot more time than having AI fix itself, right?
Exactly right.
AI is not digging the ditch, for more fiber.
And just like a historical factoid here, when the telecom network was built out, and you kind of went through these different generations, 1G, 2G, 3G, 4G, 5G, there was sort of these waves of investment, and the telecom sector actually got really good at capital efficiency and sort of what is the capital intensity. So if I put in $100 billion, at what point do I get back $100 billion plus dollars, right? And that actually affected the velocity of the deployment of multiple generations. And if you look at it as sum total, we're talking, more than $500 billion for the deployment of kind of, at least in the US, of 1 through 4G. But the data cloud environment is just not used to that as a native capacity yet. So that's one of the things I'm kind of watching and seeing whether there's more kind of focus on that comes forward. But I think we're a minute over, and so I'm going to have to cut off an amazing conversation. And yeah, I just wanted to thank you, Tab, for joining us for the conversation and also bringing a unique and important perspective.
Absolutely. And every time we have those amazing speakers, I feel we just barely scratching the surface about those fascinating discussions. So really, really appreciate and looking forward for more discussions.
Lots to talk about. You guys are great at what you do, and I appreciate the time. Thank you so much.
Awesome. Thanks so much. Thanks, everyone.
Right. Have a great day.